This is our video for Unit 5, Day 2. So there's a warm-up on these notes, so if you could just listen to these instructions, then pause the video and try this warm-up on your own. Just take a few minutes, try it on your own, and then keep going through the video. So what we're doing in this warm-up is just solving an equation for a variable. So what that means is to get the variable by itself. So pause it here, just take about 2 or 3 minutes, try and do each of these three on your own. Once you've had a chance to try them on your own, we'll go through this together. So this is something we did back in Unit 3, is solving equations for variables. All that means is we manipulate everything in the equation to get everything else besides that variable on the other side. So on this one, where we're solving for y, we're going to subtract 4x. We'll cancel it on the left side and bring it over to the right-hand side. And I'll go ahead and divide by 2. Said it's solved out for y. Right, so y is completely isolated on the left-hand side by itself. So now it's solved for y. That's the same idea on number 2, we're solving for b. So it looks at the equation. Here's the only term with b in it. So first things, let's move the other terms to the other side, combine like terms. And then here we have a negative b, so we can divide by -1. Cancel that out. Alright, now on this last one, now we're solving for x. So again, we look where our x is, or our x term. So first I want to move every other term to the other side. So here I'm going to take the 3y away from both sides. Right, if that was a negative 3y, I'd be adding it. Since it's a positive 3y, I'm going to subtract it. And since x is being divided by 2, I'll multiply by 2 to cancel that out. Alright, so this stuff up here at the top is just working with algebraic manipulation. Alright, which is just saying moving things around in an equation. Alright, we also did this back in Unit 3. It's our video for literal equations. So we're going to have to use this skill today when we start solving systems of equations algebraically. So, getting into what we're doing today is solving a system of equations. So we talked about what that was back in the second unit when we solved them graphing. We went back over that yesterday. Reviewed how to solve by graphing, find the points of intersection. Today we're going to be solving them algebraically for the first time. So system of equations is a set of 2 or more equations that use the same variable. So most of these you're going to see they're going to use x and y. If we solve a system of equations, we have to find all the points, which means x and y both, where the 2 equations are equal. Right, and just like we talked about yesterday, same thing as finding the intersection of the 2 graphs. So today, the process we're going to learn is solving a system of equations by substitution. One of the biggest problems you see with doing these problems is sometimes you'll get an answer for x and you think you're done, but these are points. That's why I underlined that, circled x, y. We have to find x and y both. We're finding points of intersection, so we need both x value and a y value to write a point. So we'll take you through this example and then 2 more, and then save the other ones on the back side of this page for you to work through on your own. So the first step here, you'll see while we practice this in the warm-up, is to solve for any variable in the equations. This can be x or y. Doesn't matter which one. So what we like to do is look through 2 equations and see if there's a variable that's easy to solve for, or sometimes the variable will already be solved for. So here, y is already solved for. Alright, so step 1 is already done for us on this particular one. Second step, this is why we call it substitution, is we actually substitute what's on the other side of that equation into the second equation for that variable. Alright, so it sounds a little confusing when you say words, but here's what we're actually doing. We're taking all this stuff on the other side that says it's equal to y, and we're going to plug it right in here where I have a y in the second equation. So when we make that substitution, it's always good to use parentheses, make sure you're keeping everything straight, and distribute anything if you need to. Alright, so if we look now, the only variable in here is x. So this is just a regular linear equation now. So what I can do now is actually solve for that variable, so I can solve for x. So here, since I have a plus sign and nothing in front of it, I can go ahead and drop the parentheses. 3x plus 4x plus 1 equals 10. Combine those two, be 7x plus 1 equals 10. Subtract 1 on both sides. 7x equals 9, and then divide. So x is 9 over 7. So we've done a lot of work, but we're still not done yet, because we only have x, we still need to find y. So the second part is I'm going to substitute again. I'm going to take this value, I'm going to plug it back into either equation to get my y value. So I can plug into whichever equation is the easiest. So in this case, when I look at those two equations, I think the first equation might be a little bit easier to plug into. So I'll take 4, I'm going to plug in this x value, 9 over 7, plus 1. So I'll go ahead and multiply. 4 times 9 would be 36 over 7 plus 1. And using the common denominator, 36 over 7 plus 7 over 7. And it's going to be 43 over 7. And our last step is to always write our answer as an ordered pair. So here we'd write this as 9 over 7 is our x value, 43 over 7 is our y value. Now, sometimes we will get fractions. Most of the examples we have here, you're going to be getting whole numbers or integers. So make sure you check your work. Be careful, but know that sometimes you are going to be getting fraction answers, and that's fine. When you're working in Math 2 next semester, most of your answers are going to be fractions, so you need to get comfortable with that as well, working this process through with fractions. So in terms of thinking about the steps, going back over what we did, the easiest way to think about it is look at the bolded words here. Solve, substitute, solve, substitute. Alright, so that's the process we're solving. We solve for variable, substitute for that variable, solve, get a number, substitute that number back in, get the other value. Alright, so we're going to do the same thing with these last two examples, go through and solve them by substitution. And then save the 4 on the bottom for you to practice on your own. So the first step is to solve for variables. So again, I like to look for the easiest variable to solve for. So looking at this practice problem on the left, I think y is probably the easiest variable to solve for. Right, all it has to do to solve for y on this equation is to add x to both sides. Right, and then remember, once I solve, the next step is substitute. So I'm going to take this expression, it's is equal to y, plug it into my other equation for y. Remember, always put it in parentheses, make sure we're not missing anything. Alright, so I just substituted, so now I solve. So I'm going to have to distribute this negative, that's why we use parentheses. Combine our like terms. Here I'll be adding 4 on both sides. Got 2x equals 10. And then my last step would be divide by 2. Remember, even once we get here, we're not quite done yet. So we still have to find our y value as well. So we take this number, and we're going to plug it into one of the original equations for x, and use that to get our y value. So if I look at this original equation, it looks like that first one is going to be the easiest one to plug into. So I'd have negative 5 plus y equals 4. Add 5 on both sides, and y equals 9. Right now, this is our full answer. We have x is 5, y is 9. Write it as an ordered pair. 5, 9. So we got one more we'll do as an example, and then you'll have some time to try the other 4 on your own. So this one, looking at this expression, doesn't look like there's doesn't look like either equation has a very easy variable to solve for, but if I'm looking, looks like 2y might be the easiest to solve for just because it has the smallest coefficient. So if I solve this one out for y, I have negative 7x plus 2y is 31. I'll add 7x. So I have 2y, 7x plus 31, and then divide by 2. So now I'll take this expression, I'm going to substitute it in for y in the second equation. So same process we did before. These numbers aren't quite as nice, but it's still the same process. So here, as we're multiplying, we're distributing through the parentheses. We can use our cross cancellation. 6 over 2 is the same as 3 over 1. So once I multiply through, I'll have 21x plus 93. And again, combine like terms. I have 31x plus 93 equals 0. Can move that 93 to the other side by subtraction. Then last step would be divide by 31. And there's my x value, negative 3. My last step here would be take this x value, plug it into one of these equations, and get back a value for y. So here I'd have 10 times negative 3 plus 6y equals 0. So negative 30 plus 6y is 0. And working that out, we see that 6y would have to be positive 30, so y would have to be 5. Again, our last step is to write it as an ordered pair. So negative 3, 5 would be our answer for this one. Alright, so there's 4 problems on this page for you to practice and get some work in on your own. So make sure you're comfortable going through this process and trying to solve these by substitution. If you need help or want to look up additional resources, you can search for solving systems of equations by substitution. Just sit down on your computer, and there might be some other videos or resources that'll help you. Alright, but take some time right now. Try and work through those 4 problems. Get them started. See if you can work these through on your own following this same process.